Today's video will be on rules, tables and graphs. There should be a comma there. So rules, tables and graphs. Okay, so our learning goals for today, we've only got two. The first is that by the end of the lesson, we'll be able to plot a graph from a given rule. And the second is by the end of the lesson, you'll be able to check if a point lies on a line. Okay, so there's some key ideas here and a few key words that you'll have to memorize. So a rule is an equation which describes the relationship between two or more variables. And this is especially important with Cartesian planes because pretty much everything we graph will have some sort of rule related to it. And a linear relationship results in a straight line graph. So if you ever read, the words linear relationship, you're going to be plotting a straight line. So that can also help you check your work, because if you graph something and it's not a straight line and the question has asked you about a linear relationship, something's gone wrong somewhere, because linear means a straight line. Okay, so for two variables, a linear rule, so there we go, linear rule. So this is a rule relating two variables. In this case, it'll be x and y, and linear, meaning we're going to graph a straight line. So the rule for a straight line is often written with y as the subject. So y is written to the left by itself, and then the rest of the rule is written on the other side of the equal sign. So to graph a linear relationship using a rule, we follow a few steps. So the first step we do is we construct a table of values, finding a y coordinate for each given x coordinate, and to do that we substitute values of x into the rule and we solve it, and that'll give us a value for y. The second thing we do after we've done up that table of values is we plot these given points onto a table, plot the given points from the table onto a set of axes, so onto our Cartesian plane. So then we'll have all these dots plotted on, we'll have all the points plotted on. We then get our ruler and we join them up and construct a line, and the last thing we do is we actually label that. So we've got a few examples, because it's easier to see example than just hear me tell you what to do. Okay, so our first worked example. We've got a rule here, y equals 2x take 1, construct a table and draw a graph. So these will all be linear rules, so we know we're going to get straight lines. So construct a table and draw a graph. So what that means is we're going to drop a table of values. So a table for x values and a table of y values. So we'll have x and y. In your books you will use a ruler. With the technology I am using, it's a little bit hard to draw straight lines. I'll have a go with my ruler, see if it'll work. So it's convention that our values for x, we start at -3. Oh look, oh it's not great. And we go all the way up to +3. So we do -2, -1, draw a straight line here, 0, draw a straight line, 1, 2, oh, rub that out, that's a bit far away. There we go, 2, and 3. As I said, yours will be done with a ruler. It'll be spaced out and it'll look a lot better than that. But this is our table of values. As I said, convention is we go from -3 to +3. So now we've got some values for x, and we just have to work out the value for y. And to do that, we're going to substitute those values for x into our formula. Into our rule. So we're given the rule that y equals 2x take 1. Now, we've got a table that's got full of these x values, so what we're going to do, we're going to substitute those x values in to find the y value. So for the first one, we've got x equals -3. So we've got x here, and our values of x, the first one is -3. So we'll substitute that in. So 2 times -3 take 1 should give us our value of y. 2 times -3, positive times a negative is going to give us a negative. 2 times 3 is 6, so -6 take 1. A negative take a positive, it's going to give us -7. So for that case, our y is equal to -7. Now, I do not have enough space here. In your book, you should be working down the page, setting this all out nicely. I'm going to go across the page. Please, in your book, go down the page. So in our second one, we've got y, 2x, take 1, 2x take 1. And this time x is going to equal -2. So we've got 2 times -2, take 1. Positive times a negative is a negative. 2 times 2 is 4. So -4, take 1. It's going to give us -5. I'll just grab the eraser and rub some of this out so we can start again. So obviously in your book, do not rub this out, just keep writing down the page. So writing all your values of x, substituting them in, going down the page. As I said, I just do not have enough space on this one little slide to do that, so I'm rubbing these out. Do not rub them out because obviously in a test situation or whatever, you get marks for your working, and in a normal situation, if you make a mistake, you need to be able to go back and see what's happened. Okay, so if y equals 2x take 1. Now, in this case, x is going to equal -1, so 2 times -1 take 1. Positive times a negative is a negative. 2 times -1 is going to give us -2 take 1 equals -3. Y equals -3. Now, if you look at this table, you will start to see a pattern. Obviously, the pattern with our x-axis is it's increasing by 1. So -3, -2, -1, 0, 1, 2, 3. So we're adding 1 each time. If you look at our y-axis, you can actually see another pattern. So -7, -5, -3. The pattern with our y-axis is it's actually increasing by 2 each time. So -7 plus 2 is -5, -5 plus 2 is -3. And from here, I'm going to use that to finish the rest of the values. So -3 plus 2 is going to be -1, -1 plus 2 is going to be 1, plus 2 is going to give us 3, plus 2 is going to give us 5. Okay, so we've got our values there. The next thing we're going to do is we're going to plot these onto a table. So I'll just use the eraser again and rub this out just so you can kind of see it a bit more clearly. I know my eraser isn't the best. Just erase that. Okay, so hopefully that's a little bit clearer. So we're going to plot these. So we know that coordinates are given in an x, y kind of format. So the x coordinate is first and then the y coordinate. On our table here, we've actually worked out all these points in an x, y format. So for instance, x is -3, y is -7. We can use this table. When x is -2, y is -5. When x is -1, y is -3. Oh, -3. When x is 0, y is -1. When x is 1, y is also 1. When x is 2, y is 3. And when x is 3, y is 5. And we're actually just going to plot all of those points onto our Cartesian plane. So the first one, -3, -7. So we're going to find -3 on our x-axis, which is here, and drop it down to -7, which is this point here, right on the border there. Our next one, x is -2, so find -2, drop it down to find y is -5, which is here. -1, -3, so find -1 for our x, drop it down to -3 for our y. Our second one, x is 0, so that's in the middle here on the origin there, and y is -1, so we can drop it down to find the -1. So this would also be called our y-intercept, because this is the point where our straight line will cross that y-axis. It's at -1. So our next point, x is 1, y is 1, so we find 1 on the x-axis, move up to meet 1 on the y-axis. Next one, x is 2, find 2 on our x-axis, move it up to meet 3, y is 3, which is here. Last one, x is 3, find 3 on our x-axis and move it up to meet y is 5. So now you've plotted all these points on your graph, and you can see that they're kind of forming a line. So what you can do is you can just grab your ruler, mine will not be as straight as yours will be, and connect them together using your ruler. I don't have a ruler, so I'm trying to freehand it, but you will use a ruler. So you can extend that out, put a little arrow on the end there, put an arrow on the end here, and then label it. So we label it with the rule, and our rule was y equals 2x, take 1. And that's how we go from a rule. We construct a table of values. Remember, we used -3 to 3 for our x values, just a convention. We substitute those x values into our formula to work out the y-axis. From there, we plot each of those points onto a Cartesian plane, draw a line connecting them, little arrows on the end if you want, and then label it y equals 2x, take 1, because that was our rule, or whatever your rule would be. We've got another one. Another example here, decide phi, I think that should say if. So decide if the points 1, 3, and -2, -4 lie on the graph of y equals 3x. Now, there is two different ways working that out, the easy way and the hard way. So the hard way would be to draw up another table of values, substitute in those values of x to find values of y, plot it onto a graph, and then look to see if those points are on it. Or there is an easier way. So y equals 3x. That's our rule. So we've been given these points, so 1 and 3. We know this is the x value and this is the y value. So what we can do is we can actually substitute this x value into our formula, work it out, and see if when x equals 1, according to this formula that we're given, will we get this y value? If we do, we know yes, that point will fall on that line. If we get a different value, we know no, that point would not fall on the line. So y equals 3x, so 3 times 1 in this case. So 3 times 1, 3. So y equals 3. So that was the point we were given. So yes, that point would fall on the line. So we'll write a word answer. So yes, the point 1, 3 falls on the line of a graph with a linear rule of y equals 3x. So for our second one, we're going to do the same thing. We know our x value and we know our y value. So we're going to substitute that x value into the formula and see if we get our y value. If we get the same y value, we know yes, it would fall on that line. If we get a different y value, we know no, it wouldn't fall on that line. So y equals 3x. In this case, our x is -2, so 3 times -2. Let's put that in brackets. Positive times a negative will give us a negative. 3 times -2 is going to give us a -6. So y equals -6. And that's different to the y value that we got. So we know that no, that point, -2, -4, does not fall on the line of y equals 3x. So no, the point -2, -4 does not fall on the line with a rule of y equals 3x. And that would be our answer there. So that's all we have for today's video. Make sure you've copied down our worked examples and you've copied down those key terms at the start as well. If you need help, please come and see me in class.